Students, in this session we are going to learn about inverted file structure. So in the previous session what we have seen about the Potter's stemming algorithm. Okay. Second one was document based and one was dictionary based. So in the dictionary based we have seen all the suffixes. According to the suffixes we have removed the suffix and we have selected the key value. We have done that. Now what we are going to do in inverted file structure. So in the inverted file structure we have three things. First one is the inversion list, dictionary, and what is your inverted file. So before starting explanation of this, just we'll go to the next one. I'll show you the diagram which will be easily understandable. Yeah. So if you take the three files, so what was the first file? As I said, we have the document file. So you have the document file, you have the dictionary, and what is the inverted list. Okay. So if you take here, in the document, whatever the data you are going to store, so that is your document, computer, bit, byte, whatever it may be. In the dictionary you are naming with bit 2. Okay. So second one is memory and byte. You are storing with byte 3. You have computer bit memory, computer 3. Fourth one is byte computer memory. Now how you are going to create the inverted list? So if you mention this, the inverted list is bit 1, 3. This is byte 1, 2, 4. This is computer 1, 3, 4. And memory is 2, 3. So this particular inverted list will be composed according to the structure of your document and what is your dictionary data. So the meaning of this is bit 1, so this is your first bit, and how many values are there in the document? 1, 2, 3. Okay. So similarly byte 1, 2, 4. So what is the thing you are going to store in the document and what are the values you are going to mention? So you will letter, suppose if I take 1 before that. So if you take here computer, I will number it as 1 bit. Okay. So I am numbering as 3 byte. I am numbering as 2. Memory is yeah. So byte computer bit memory. So one more was memory because we are storing here memory. Now if you take computer bit byte, so what was the order? You have computer bit byte, so you have 1 3 and you have byte 2. So actually here you'll have 1 3 2. Next one is memory and byte. If I take 4, so memory and byte, you should have 1 is your computer, so here you'll have the computer. So computer 1 2 4. So 2 is your byte, 4 is your memory. Next one is computer bit memory. Computer is 1. So bit is your 2 and memory is your 4. So byte and computer you will have 2, 4. Okay. So please do. Just you change these values accordingly. So this is the storage of the inverted file structure. So in the document your data will be stored. In the dictionary how many bits you are mentioning in the form of byte or bit. Then you are giving the names and accordingly you are creating the inverted list. So what is the basic thing we have done? So these three are over. We have seen the files, and for each word of the documents the word is found in the version of inversion of the document, and each document is given the unique numerical identifier. So this is your unique numerical identifier which you are going to store, and dictionary is used to locate. So this particular dictionary is used to locate these values in the document. So these three are interlinked. So whenever I am taking bit 1, 3, this will be in the dictionary and dictionary will be located according to the document. So what are the advantages of this particular formatting is you are going to use zoning. Zoning in the sense you are finally the complete documents are numericalized, where you are directly taking the values and you are fetching the data, and it will helpful in the precision and restrict values. For example, This complete document will contains only 3 words, right? Computer, bit, byte, memory. Yes or no? So only these words. So when I am searching these words, if I got mouse, I think you are getting. So mouse. So by seeing the inverted list, I'll go to the dictionary, and from the dictionary I'll check the document. I can understand that I don't have the mouse word in this particular inverted file structure. So I can skip this particular search. Like that, whenever you are going for the new other words, you can do it. If I'm searching for the bit, so immediately by seeing this particular thing, so because I have bit, byte, computer, memory. So immediately after seeing your inverted list, it will check, and at the first step only it will say that your value is found in this file structure. Okay, so these are the basic fundamentals you have to remember while structuring this. Okay, so example, you are taking bit 1, 12, 18. So these are present in the, so bit 1 is present in 10, 12, 18 positions. So word in the document 1. For example, so where is bit 1 present in your 10, 12 and 18 positions? So when your search is performed according to the inversion list, in order to locate your bit, so it may search in 10, it may search in 12, or it may search in 18. For example, I can also add the weight values for this. I'll say that 1, 0, 1. So which will have the highest weightage? 1. So I'll skip the 0 weightage. Again I can search 1, 1, which is at 12 and 18. Okay. So this can also be mentioned over here. And suppose if you have any special characters in the given word, you can create a separate dictionary called special characters, and you create all the special characters star, dollar, hash. Then you can mention the name as this. So whatever the special characters are available in your word, you can mention, and you can mention the address like this. So at 10 star is available, 11 dollar is available, 12 hash is available. So this can be done in your own dictionary. Another example is related to your date. So if you are taking the date will be ranging from numbers. For example, your dates will be only the digits from 0 to 9, right? And also if you take month, whatever it may be, it will be 0 to 9. And if you take the year also, again it is 0 to 9. So this range cannot be removed. So what you can do is, you can range of numbers you can mention. All the dates will be present like this in the dictionary, where the range will be from 0 to 9. So immediately whenever you are getting the date, you can divert this particular list, the structure, to the date inversion file structure. Next one also, you can go for the ranking. So you can also support the ranking. For example, I am storing the data like this: 1, 2, 3, 0, 7. Suppose if I want to go for ranking based, so I can also use either, you can sort according to ascending or descending. So you can use ascending or descending order, you can sort everything. When you sort that, you will get 7 will be the highest one, and you can rank this one. Okay, so ranking can also done. Next one is B trees. So in order to store this particular ranking values, you can also use the B tree data structure. Okay, so and also you may have the equal priority values. So wherever you have leaf level or referenced in the higher level priorities, but when you are having the same level, so if you see here how you are going to mention when they are at the same level. So if I have higher priority B trees, you can again divide into values, and you can also divide. If I mention 0 to 10, so here 0 to 5, 5 to 10. So all the 0 to 5 values, 1 to 3 will be here, and 5 to 10 means 9, 10 will be here. So these are at the different levels. But if I have the value called 0, 0, so how you are going to search this one? Simply you can create one dictionary for the same level, all zeros will be there. You can locate according to this. So this will be at the same level. So if you take the B tree, so already we know how the B tree will be there. So this is our B tree. I'll mention from 0 to 10 and 10 to 20. All the values, again here you will have the values from 0 so on up to 10, and here you will have the values from 10 to so on 20. So this is a basic level order you can use. So you will have the root with between 2 and 2m keys. So you can use any keys values, and all the keys are kept, remember, smaller to larger. So always it will be in the ascending order. Okay, so here I'll take 11. I cannot mention here 11 to 20 and 0 to 10. So this is wrong method. Only thing is all the keys should be in the ascending order. Thank you.